We have an example problem here. The maximum speed of a 3 kilogram object in simple harmonic motion is 6 meters per second. The maximum acceleration of the object is 5 meters per second squared. What is the period of simple harmonic motion? So in terms of what we know, they've given us the mass of the object, so 3 kilograms. The maximum speed, so Vmax, is 6 meters per second. Maximum acceleration is 5 meters per second squared. And we want to find the period. So simple harmonic motion, we're talking ideal oscillations. Let's look at the equations that we know apply. So, we know Vmax is omega times A. And Amax is omega squared times A. We know Vmax and Amax. We do not know omega or A. If we can find omega, we know omega is equal to 2 pi over t. And so period would be 2 pi over omega. So if we can find omega, that will be great. So let's see. If I divide these two equations by each other, I could say that Vmax over Amax is, the A's will cancel, one of the omegas will cancel. So we would end up with 1 over omega there. Okay. We know that omega is 2 pi over t. So if I substitute that in, I now can say that Vmax over Amax is equal to the period over 2 pi. We're given Vmax, we're given Amax, so we just need to plug everything in now. If we solve for period, we end up with the 2 pi times Vmax over Amax. So 2 pi Vmax is 6 meters per second. Amax is 5 meters per second squared. And the meters will cancel, one of the seconds will cancel. So our answer will be in seconds, which is great because that's what we need. So 2 pi times 6 over 5. I have 3 sig figs, so 7.54 seconds would be the period. So as I start solving problems, I just start writing down the equations that I know would apply, and in this case we ended up with 2 equations and 2 unknowns. You could very easily have solved for A in one, put it in the other, and you would have ended up with the same relationship.